Now we're going to look at section 2.1, but the second part. So we've organized our data. We've learned how to create these frequency distributions or frequency tables. We've learned how to calculate things like classes and class midpoints and boundary points, count the frequency, find relative frequency, cumulative frequency. So we've done all the organizing part. And in the second half of 2.1, I want to look at all the graphing. So we're going to start with some graphs in this section, particularly focusing on histograms, and then we'll continue with graphing in the next section as well. So what I have here on the handout is just a recap of what we did really in the last couple videos. So we have that first example that we've been focusing on of out-of-pocket prescription medicine expenses in dollars for 30 US adults. So you have that original data set here that we worked with in the last few videos. And then this is basically all the work we did. I just kind of consolidated it into one table. So typically when you're doing a frequency table, usually we have the class and we have the frequency. Those are the main two pieces that you need, right? So you need your classes, which are your intervals, and then you need your frequency, or which are your counts. So how many data points are in each interval. We also learned, though, that we can find what's called relative frequency, and these are basically your proportions. So you're looking at your frequency out of your total. Typically, we use this decimal form, although you could use percents by multiplying everything by 100, but usually in stats, we tend to use the decimal form. And we also talked about cumulative tables as well, which basically add up the rows each time you go down, so you get to the final total of your sample. On the other side, we talked about a couple different calculations with classes. So we learned how to find the class midpoints, which is the halfway point between your interval. And we did that by finding an average. So we added the 155 and 190 divided by 2. And then we also found our class boundary points. So here again, I just organized them a little bit nicer instead of just kind of writing them above and below. But these are your halfway points between the intervals or between the classes. So notice that your classes or your intervals always have gaps. Okay, so nothing should ever overlap. There should always be some sort of gap in between. So here you have a gap from 190 to 191. So your boundary points are the halfway point between your gaps. Because everything is whole numbers here, the halfway points are going to be always halves. I apologize, I wrote a 6 there. Let's fix that. That should be 0.5. So we have all those boundary points. And then just keep in mind, you do have to do a boundary point at the very beginning and at the very end. So you can follow that same pattern. So because everything is whole numbers, our boundary points occur at the half points. So your final boundary point is 406.5. And then your beginning boundary would be the 154.5, so half unit below. And this is what we worked on last time. So in our videos for this lecture, we're going to be looking at the graph, so the visuals of all of this. And the main one that we tend to focus on is the histogram. That tends to be the big one in statistics, although there's other graphs we're going to see. So other graphs are good too, but histograms tend to be where we're going to start a lot of times. So how do we take this information and how do we put it into a histogram? So first of all, a histogram is a type of bar graph. Okay. So you're going to see bars. There's lots of different kinds of bar graphs. So a histogram is one particular type. So things that you're going to notice is that the horizontal scale is quantitative. So your your horizontal, your let's say axis there is quantitative. So it's going to have numbers on it that measures the data entries. Your vertical scale, so your up and down, that would be like your y-axis, measures the frequencies. So the heights of the bar are going to be associated with the frequency for that class. Here's the thing that's important with histograms is that your consecutive bars must touch. So your bars are touching in the bar graph. A lot of times bar graphs have spaces in between, which is fine. It's just not a histogram. So in histograms, those bars are touching. When we're designing these histograms, Boundary points or class midpoints are used as tick marks on the horizontal axis. So that's really key. On your horizontal axis, you're not usually listing the classes, you're usually listing the class midpoints or boundary points. Your vertical axis must begin at 0 in order for the bars to be the proper scale. So a correct histogram should have their vertical axis beginning at 0, because your bar heights should be proportional with your data. So they should be in the correct proportions or ratios. When we don't start at 0, they get squished, so they don't work the right way. So we should always start at 0 in a proper histogram. And because of this, histogram bars should be in correct proportion to each other. So for instance, let's say that one class has a frequency of 2 and another class has a frequency of 4. So you have 2 and 4. So those are going to be the heights of your two bars. And the height of 4 should be twice as tall as the height of 2. So that's what I mean where they're in proportion. So they should be, the height should be correct. If something is 4 and the other one is 2, then the 4 one should be double the size of the 2 height, right? So they should be in correct balance with each other. And that has to do with making sure your axis starts at 0. Now, I did make a point here about things not being in the text. So these things are covered, but I don't think they're very clearly marked in the text. So if you look at your text pictures, they do all of these things. But I just want to really point them out because I don't think they're as clear in the text as they need to be, is that we always start at 0 so that our histogram bars are in the right proportion on that y-axis. And for our x-axis, our horizontal, we use midpoints or boundary points. A lot of times students try to use the actual classes or something like that, but really we should be using either midpoints or boundary points. All right, so let's look at an example. So here are the examples, and I just copied these all from the text. I just wanted to make it a little bit easier for me to talk about it with you rather than constantly flipping through the text pages. So here are the histograms that are related to the data that we did the other day. So let me show you how it works. I'm going to zoom out a little bit. Okay, so what you want to notice are a few things. So first of all, your vertical scale is starting at 0. So I know they don't really write it in, but there would be a 0 there, right? And then you're counting up 1, 2, 3, 4, 5, 6, 7, and so on. You don't always have to count by ones. It depends on your data. If you have very high frequencies, you could count by 10s or 50s or 100s, whatever you need to, but you should still start at 0. You want to know the height of the bars are the same as the frequencies in each class. So each of these bars represents a class. Okay, so notice here that your first height is 3, and then your frequency was 3. Here, your height was 2, so your frequency for the next class was 2. So that's where they're getting those heights from, and to know how high to make that bar. Here, you have 5, 5, 6, 6, 7, and 7, 4, and then, of course, 3. And this is actually the same histogram. They just have two different numbers on the x-axis, so I'll talk about that too. But you can see the heights are all the same. Now, because we're starting at 0, the bars are in the correct proportion to each other. Notice, and I'm just going to kind of draw on the pictures here. So see how this height is 2 and this height is 4, right? If we kind of draw across, you can see, so here's where the 2 height is. You can see that that bar of 4 is double the size of the 2, right? If this is the 2, you can see that 4 is double that. So our proportions are in line here, and that's really important with histograms. And it works for all of them, right? So look at here, your height of 2, let's do 2, compared to 6. So 6 should be 3 times as big as 2, right? 2 times 3 is 6. So if you look, there's 1, 2, there's about another 2, and then there's a third 2, right? So you can see that the 6 is 3 times as big as the 2. That's what you want. Histograms are supposed to make it visually easy for us to see which class has the most, which class has the least, how much more, right? So as a ratio, is it times 2, times 3, times 0.5, whatever it is. So they should be easy to read. So it is important to start at 0. And this graph does the same thing. Now, a couple of things you want to notice. Like I mentioned before, there are 2 ways that you can write your values on your x-axis. So this one on the left uses the class midpoints. Okay, and you'll notice that the tick mark occurs in the middle of the bars. Okay, so if it's a midpoint, it's a point that occurs in the middle, right? So this is one way to label your x-axis, is to use those class midpoints. And you can see, again, we calculated those last time. You can see they're matching, right? 172.5, 172.5. The next one was what, 208.5, and then 208.5. So you've done all the calculation organizing first, and now your histogram, you're displaying. So all this work should be done. It's just a matter of putting it on the grid and drawing your bars in. On this side over here, they're not using class midpoints. They're using class boundary points. And the tick marks occur on the ends of the bars. So notice here, your tick marks, how you're labeling, are occurring on the ends of the bars, not in the middle. That makes sense because your boundary points occur outside the classes, right? They're that halfway point between the 2 classes. So they're on the ends of the class, of the classes, right? On the ends sort of the class width there. So that's why your tick marks are on the ends of the bars. And again, you can see them up here, right? 154, 190.5, 154.5, excuse me, 190.5. And then the next bar was 190.5 to 226.5, right? So you can see all those values there for the boundary points. So that's another way to do it, okay? And again, we do use boundary points often as well, so we can get those bars to touch, right? Because we're kind of giving a spot for that space in between the classes. So using those class boundary points allow us to let those bars touch as well. All right, now one last thing I want to talk about here on this graph is, and they mention it here and here, is this idea of a broken axis. Now, this is really just a symbol to show that some values are left off. So if you look here, you know, our horizontal axis should start at 0, right? But I have no data before, in this case, 172 or 155, we'll say. I don't really want to have to draw 170 tick marks that have nothing on them. So we use this little symbol here just to show that we have kind of truncated or condensed that part of the bar so that we're not starting at 0. We're going to start at 172 or 154, whatever it is. So we use that symbol just to note that, yes, we acknowledge that we have cut off part of that axis, right? We're not starting at 0 here. And we've made that note. And this is fine to do in a lot of cases. So if I have no data on my x-axis below 154.5, again, there's no need to have a whole big blank space there. So we're just making the graph easier to see. You do want to be careful with that on a vertical axis. Like I said, sometimes people will cut their vertical axis. This can be a problem with any sort of bar graph. So if you have any bar graph or histogram, you never, never, never want to truncate or cut that vertical axis. Even if your frequencies start at 1,000, you still have to have that starting 0, or else the bars will not be the correct heights and proportions to each other. Sometimes for line graphs, and we'll talk more about that later on, but sometimes for different kinds of graphs like scatter plots or line graphs, things that you may have seen in a more traditional algebra class, it may be okay to not start at 0 as long as we're not distorting the data. So that's kind of done on a one-to-one basis by the professional who's creating the graph. If your data doesn't start till 1,000 and you can correctly space so that you haven't squished the data or elongated it, then it may be okay to not start at 0 on a vertical axis, but that's done on a one-to-one basis with the problem. and never, never, never with a bar graph. So your bar graphs must always start at 0 on that vertical axis.